Good afternoon, my YouTube viewers. In this particular video, what we're going to be covering is a paired t-test concerning a diet. And basically, this is a practice question. And we're going to be using the t-distribution to answer this question. And the t-distribution is similar to a normal distribution, except for the fact that the tails of the t-distribution are heavier than the tails of the normal distribution. So the practice question that we're going to cover is, a dietitian wants to test the effect of a new diet plan. 10 participants' weights were measured before and after the diet plan. The differences before minus after are as follows. So it gives you 2, 3, 1, 4, 3, 2, 3, 2, 1, 4. And what we're going to do is, in order to answer this question, what we're going to do is we're going to do a paired t-test. And we're going to write a program in Python to do it. So in order to execute the program, we're going to import scipy. So from scipy, we're going to import stats. And stats is a statistical module within scipy. And scipy is Python's scientific library. So we're going to get our before weights, which is a list of 10 numbers. And we're going to get our after weights, which again is a list of 10 numbers. And the difference between the before and after is what we've already discussed, being 2, 3, 1, 4, 3, 2, 3, 2, 1, 4. And then we're going to perform a paired t-test. So t-statistic, p-value equals stats.t-test_rel before, after. And basically, t-test_rel is a paired t-test. And what that means is the values are related to each other. And then whenever you do a t-test, you need to make sure that you're using the correct t-test. Because you have one t-test, which is an independent t-test, which we have used earlier. We used an independent t-test earlier. And if you try to use an independent t-test on paired values, your answer is not going to come out correct. And if you try to do a paired t-test on independent values, your answer is not going to come out correct. So that's why you need to make sure that you're using the correct test. And in this test, since you've got 10 people on a diet and you're just measuring their weight before and after the diet, this is going to have to be a paired t-test. Okay, so we're going to print the t-statistic and the p-value. And then so your alpha is going to be 0.01. That's your significance level. So you'll notice most of the time when we have been doing questions, the significance level has been 0.05 because that's the standard. But it doesn't have to be 0.05. It can be any number that you want. It can be 0.01, which is what we're using in this instance. Or it could actually even be 0.1. It just depends on what the researcher wants. And in this particular instance, the researcher wants 0.05, 0.01. So your significance level is going to be a lot less than it has been in previous questions that we've gone over. So if the p-value is less than alpha, which is 0.01, you're going to reject the null hypothesis. There is a significant change in weights after the diet plan. But if the p-value is greater than 0.01, you're going to fail to reject the null hypothesis. There is no significant change in weights after the diet plan. So we run up our t-statistic, which is 7.3193. our p-value is 0, and so you're going to reject the null hypothesis. I don't understand how they got that. It says reject the null hypothesis. There is a significant change in the weights after the diet plan. So the p-value is less than 0.01, so the null hypothesis is rejected. And there is a significant change in the weights after the diet plan. So that concludes this particular video. The next video is going to be on machines, so I hope you decide to watch it.